Good morning, everybody. I'm doing a review actually of one of my videos, a Titan 10M Operation 2 video. And actually some comments I got on the video was really about how long the part took. That's really a feed and speed lesson. Let's put it that way. So some would Titan gave an estimate of 15 minutes to complete the part. I had an estimate on my um, program I did on Operation 2, and I have a lot of settings I in my video of feeds and speeds and other settings to use. Um, to get deeper into this, when you get into a lot of machining and any 3D surfacing, there's going to be a time element in there. Uh, 3D surfacing, like the Titan 9M and 10M, have 3D surfaces, which require ball milling. That's typically what most people use is a ball mill. You can use a bull mill sometimes, but we're being taught to use a ball mill, and it works just fine. So, first thing you need to know is what RPM do you need? So that's like the first thing. I'm going to bring up a chart here. I use these simple feed and speed charts. I'm not promoting any particular brand. This applies to Kennametal, helical, all kinds of end mill companies, right? And this is the basic concept of how do you calculate RPM. So, so the basic concept is what material are you cutting? That's pretty much the first thing. We're all using carbide end mills. So this is our carbide end mill chart, little basic one. And every company has one. And they're all kind of in the same category. You start up the top, it says aluminum alloys. And it says right there, SFM, surface feed per minute. That does not say RPM. Now, all Titan's videos, he talks all the time about cutting speeds and feeds, RPM, surface feed per minute, chip load. This is when it starts that you want to start letting that sink in and learn from this. So the first thing you need to know is what RPM should you be cutting. So if I went down to the bottom and it says tool steel, right? That says 100 to 300 feet per minute. And if I go all the way up to the top, aluminum alloys, it says 600 to 1200. So these are just approximations. Get you kind of in the ballpark. Another great video to watch is the Mark Terry video on how to calculate speeds and V's. And there's an inch version, there's a metric version. But this basic concept right here of a, a vehicle that has two different sized tires. So our machines run in revolutions per minute, RPM. And the manufacturers are saying SFM. So how it calculates is every time this rotates, it travels a certain distance down the road. So if you were to lay the round part and make it flat, so imagine you're driving down the road, driving down the highway at 70 miles an hour, and you got a vehicle like this. The front tires are going to be spinning faster than the back tires. So big tools versus small tools. Small tools, just by their diameter, need to rotate faster, and therefore the big tools need to rotate slower in order to be even with each other. So they're traveling along the surface in feet per minute or miles per hour. It all is the same thing. Great video to watch and get the concept down. And there's a calculation in there. It's pretty simple calculation, but all your CAD/CAM systems have that built in. You don't really need to sit there and calculate, but it's a good exercise to do. It's a really straight formula. You take your SFM, which would be, let's try 600, right? And you times this constant called 3.82 and divide it by the diameter. And that's it. That's how you calculate RPM. And that's in this video right here. So I'm going to pull up my Fusion here, right? Here's a, it applies to Mastercam, any cam system you're using. I just pulled up an old Titan 10M part, my student Pokey here. I got two operations, G54 and G55. And it says right here, I got actually the timer on here. It says 14 minutes, 34 seconds, and the second operation is 21 minutes. All right. All right, let's look at adaptive. This is adaptive on the first operation. And even says I have the timers turned on to how much time each one takes. We'll just go right down the line here. I'm going to edit the operation. And over here, it says spindle speed 8,021. And right below it says feet per minute. So I said, oh, I got 600 to 1200, and my machine goes 6,000 RPM. So this would be going too fast because I can't get to 8,000. You really need to have this correct. So if I want to align this to another machine, I need to reduce my RPM. So I can either hard type over it or recalculate the surface feet. But if I had, like, what's my max RPM? Right there, I just hit 1200 and it recalculated to 9,167. So I have a 10,000 RPM machine. I can get there. And if I click in 600, now it's 4,583. So if you have a 4,000 RPM machine, we got to go a little bit lower. We can only go to the maximum RPM. So, but aluminum is got a much higher range. Let's go back to the original chart. Feed and speeds, and if I go down here to tool steel, 100 to 300 feet per minute. Go back to my Fusion, and I type in 300 feet per minute. Now that is 2,291. So obviously, if you were to put a tool steel piece of material in there with the same tools, and you were to run it with the aluminum feet per minute thing, you would start breaking tools or have some problems. So, but in reverse, if you're running too slow in RPM, you're really not taking advantage of your machine. So, in your process. So in this case, I'm going to put this, what's it, 600? So I'm going to say I have a 6,000 RPM machine. So I'm just going to start typing in some numbers like 750. That's 5,729. I can live with that. That's almost 6. And now we have how many how many inches per minute can we go? That's really the time, inches per minute. How fast can I go in that direction? And that's what we call chip per tooth. Let's bring up our tool here. Got our tool. We have our half-inch end mill. Edit the tool. Here's our tool on the left. And as long as it's described correctly, it says 3-fluted tool. That's what I want to use. So if that's described correctly, there's the flutes right there. Here. This is how long it is. This is the diameter right there. So I got it in there, and you can do the same thing in Mastercam. As long as the tool is described correctly. Go back in here and just change those RPM. So let's see, edit the tool. Now this is pretty much exactly how Titan did it, right? So like I say, I have a 6,000 RPM machine. So I'm going to do, what's that, 750? Or I can actually just type in 6,000 right here, 6,000. Right. In my chip load, I'm going to look at the chart. I need something to go by. Right here, it says aluminum alloys up to half inch, up to a half inch, 0.002 to 0.004. That's chip load. So if I'm unsure sometimes, if I'm like running these new steels, I might just go conservative, 2, or go to the middle, or maybe just go to the middle. All right. then at the machine I could test that. Okay, over here we have feed per tooth, right here, feed per tooth. So I'm going to pipe in 0.004. And that gets me 72 inches a minute. It self-calculates, 0.003. That get me 54 inches a minute. So I think in the Titan videos, he's giving you a basic RPM that'll work on most machines, but at some point you want to be able to take advantage of what your machines can do. And if you have some basic data like this, then you can get out there and try it out. So I'm not going to go into changing all of these, but that's really the basic concept of that. So some of these I have the time on here. I actually have this turned on. If I go into Fusion here under Preferences, under Manufacturer, and I have Show Operation Machining Time right here. So I can tell what each operation does. And if, see, I'm going to probably try to load Mastercam on here. So I want to make sure everybody gets a good lesson in this. Hang on for a while. Okay, I pulled up one that I was in the middle of working on. It says here, surface speed, high speed dynamic OptiRest. This is a Titan 1M right here. And parameters. So this is my settings page. I got geometry identified, tool path control, tool, right? Right there it says 3/8 flat end mill. Here's my feed and speed area right here. So I got surface feet per minute. So if I just type in 750, that will self-calculate to 7640. Or I put in a hard RPM number, 6,000. Over here it says feed per tooth. I'm going to go with that 4,000s. And now that's 72 inches a minute, just like the other one calculated. And it's got feed rate and plunge feed rate. So normal feed rate and plunge feed rate. And they all have that. Let's go make sure the tool is described correctly. So if you downloaded his library, I got overall lengths, shank diameter. Let's go tool number, offset number, number of flutes right there. I have it described correctly, so it's going to calculate this. And you can start building your own tool library, by the way. So it'll actually have a lot of this RPM data already built in. Because there are some standards here, but these are just generic standards. All right, so that takes care of the Mastercam side. Let's go back to the Fusion. All right, the other thing about 3D machining, which is curved surfaces, is let's turn on some of that. It's actually on the other side. You flip this upside down. All right. See all that blue there? That's 3D machining. So that is that right there. And I can notice that all of these, that takes 15 minutes of the 21-minute cycle time. So that takes the most time. So just for example, it says scallop. I used scallop on that one. And notice it didn't go everywhere. It didn't go in the middle. But 3D machining is these little tiny lines. We also call that step over. So I got RPM, but our machine runs 8,100 RPM, so we wanted to take advantage of that. I have feed per tooth of 4,000s. And I will tell you, the feed and speed chart isn't necessarily applies to 3D machining. It's more of a visual thing, in my opinion. But you got to have some basic data, you know. All right, so I got 4,000 per tooth, 8,000 RPM, so I'm maxing out what my starting is there. It even says what feed per tooth is. Nice little picture right there. And that gets me my 15 minutes. Now, what are some other settings in here? I got geometry identified, avoid surfaces, tool on center. I have my heights. I have my passes. This is step over here. Step overs is how close those spaces are. So this might be time consuming. So I'm like, oh, let me just change this to 0.010, right? Step over, hit OK. Now we had 15 minutes before. Let me update. Now it's 7 minutes. I just took 7 minutes off by just changing the step over. And I may get a pretty good finish. So sometimes I have some standards that maybe I'm compressing everything too fine. But when you're on the machine, you can look at it and go, oh, that's a little bit rough. Maybe I'll change the step over down. And then what I got to the machine says, the 4,000 per tooth feed rate seems to cut very easily. I can override it at the machine and it seems to cut the same. So I can also experiment to see if I go like 6,000 per tooth, right? That's 145 inches a minute. All right, now I'm down to 5 minutes. I've cut this whole thing in half by just changing the step over. And what else did I change there? No, and the feed rate. Step over and feed rate. This is less important on the non-roughing operations. The roughing operation is a material remover, the MRR number. You're trying to get rid of the material as fast as you can. That's usually the bulk of the operation. But in 3D machining, the 3D surfacing becomes the bulk of the operation or the time-consuming part. So you got to kind of learn from that. How many RPM can your machine move? What step over looks good? Have some standards, and maybe you can push the envelope of feed rate, but basing it on the chip load thing. So you need RPM, what you're trying to do, right? What does your machine do so you can be in that range? You're not too slow. And then maximizing that. And another thing in adaptive, let's go back to the adaptive thing. I'll flip to the other side. I forgot this one. All right. Adaptive in Fusion is the passes command. It says optimal load right there. See a little. So optimal load is how much can you cut sideways. And some people use a percentage number. Now this is not percentage. It's a hard number. But it's really, if you calculate it, let's say it's a 0.375 end mill and you want to take 20% step over. And you can calculate that, or 30% step over, and say, oh, that seems to cut fine on my VF2 machine, but on my TM1 machine, it seems to struggle a little bit. I can see the load meter going really like 80, 90%, and I want to be at 50%. Or maybe it runs just fine, So that's your load, right? We got load. Those are your biggies right there. Let's go back to the Mastercam one. So in Mastercam, the settings on that would be cut parameters. On the cut parameters right here, we have step over, right? And they have it as size and percentage. You can just play with this just on size. So this one says 15% step over. So I said, oh, I think I've done 30%. Hit enter. That gives us 112 of number, step over. And that's how to increase that. That's step over by use a percentage, like 10, 20, 30% is kind of my maximum on aluminum. All right. That's pretty much you see it says the spaces right there, the spaces between each cut. Those are your basic ones. So you got your tool, RPM, chip load, and here's the other one, cut parameters, step over. Those are some of your values you want to look at. All right. So I didn't want to get into like reprogramming the whole thing, but just really the basic concept of what RPM you're going to use. I've actually found some other good feed and speed shots, but if you just have like a basic one, I don't know if Titan has a nice easy speed and feed shot to put out there, that would be a great lesson. But keep on following the videos. It's a great program, and I highly recommend it. Notice I have a nice Titan t-shirt on here, and I got that from him personally at IMTS this year. So thanks a lot. And also support Project MFG. I got my Project MFG mug here. And that is a 5-axis competition. We were in it for the second year this year. And we learned 5-axis during Titans of CNC, starting with the 139M. Okay, thanks, and I'll talk to you later.